Okay, we're in section 9.1, and this is on systems of linear equations in three variables. All right, so our objectives are going to be writing systems of linear equations and then recognizing the solutions, solving linear systems with substitution and elimination, modeling with linear systems, recognizing linear systems that have no solutions, and then recognizing linear systems that have infinitely many solutions. So when we're solving a linear system in two variables, which we've done, we can express the solution as ordered pair x comma y. Now, when we have a system of three equations, then we're going to have three variables, and we usually use the variables x, y, and z. So the solution is going to be actually now an order triple instead of an order double, and it's going to be x comma y comma z. All right, so first things first, we wanted to determine whether negative 6 comma 2 comma 5 is the solution to the system. Remember, it's x comma y comma z, so we're going to plug in negative 6 for x, 2 for y, and 5 for z in each of the equations and see if it's a solution. Now, this is really what we would do at the end of a problem, not the beginning of the problem. This is just to kind of make sure you know how to plug them in, but this is kind of your check at the very end to make sure you have the correct solution. You plug these into all three equations, the original three equations. If they're all true, then we have the correct solution. So whenever you do these problems, you'll always know if you have the right solution or not. So plugging it into the first one up here, we plug in those and it's a true statement. Plugging into the second one, though, we end up with a false statement. And so therefore, it's not going to be a solution to this system. And if we plug it into the third one, it's true. So again, you could plug it into two of them and you say, oh, it's true, and forget the last one. Well, the last one shows that no, it's not a solution to the system. And so you really have to plug into all three equations because usually what happens, especially with three equations and three unknowns, you work with two of them primarily, and the last one you don't always get the right, how do you say, way to solve it, and so therefore it's not right on the last one, but the other two are it is correct, and so this is a prime example of why you want to check your solution in all the problems. All right, so the order triple does not satisfy all three, so it's not a solution. Now here we want to look at the measure of the largest angle in a triangle is 30 degrees greater than the sum of the two smaller angles, and it's 80 degrees more than the smallest angle. Now we're going to set up a system of three linear equations and three variables whose solution gives a measure of each angle. So what we need to do is we need to set what our x, y, and z are, and then we need to write our equations. So first things first, we're going to let those be the angles from largest to smallest. Then we have to remember what a triangle is. A triangle adds up to 180 degrees. So that's going to be our key thing. So we're going to take x plus y plus z is going to be 180 degrees. So that's going to be our first equation. Now, the next one says the largest angle in a triangle is 30 degrees greater than the sum of the two smaller angles and 80 more than the smallest angle. So our first one, we're going to work with this piece. And so it says the sum of the two smaller angles, which is going to be our last two, which is our y plus z. So it's going to be x minus that y plus z is going to be 30. And so if we simplify that, distribute the negative, we get x minus y minus z is equal to 30. So that's going to be our next equation. And then the last one, we have that the 80 degrees more than the smallest angle. Well, the smallest angle is going to be our z, and so x minus z is equal to 80. And so that's going to be our last equation. And so our system of equations that we would solve would be this. X plus y plus z is 180, x minus y minus z is 30, and x minus z is 80. Okay, so that's all they really wanted was what is the three equations to solve this system. All right, so let's stop there and we'll come back for some more.